In this video, you'll learn how to build a real-time analytical backend powered by Moose and integrate it into a Next.js front-end dashboard, and how to package everything up and go to production by hosting with Boreal, the cloud hosting platform designed for your Moose projects. Now, to give a quick overview of what we're going to build and ship today, here is an architecture diagram. We're going to get started from the GitHub Trending Topics template. This is an open source template that's available in the templates folder of the Moose GitHub repository. And this application has, again, two main parts. It's got a real-time analytical backend service powered by Moose, and it's got a Next.js front-end dashboard that's consuming the data that we're ingesting and processing and storing in our analytical backend. Now, without further ado, let's go ahead and get started. So I'm going to run the moose init command to clone down the code from this open source template repository, and that'll get me up and running with a working version of this project. If you want to see the full list of templates available, you can run this moose template list command, and you'll get a list of the different template names. I'm going to go ahead and copy the name of the template that we're using. It's called GitHub Dev Trends. And then I'm going to initialize the project with moose init. I'm going to name my project my GitHub Trends app. And then as my final command line argument, I need to actually paste the name of the template that I want to start with. So that has been created for me. If we go ahead and check out the structure of the project, you'll notice I've got a mono repo with two subfolders. I've got a dashboard folder, which contains all of my Next.js frontend code. And then I've also got a Moose backend folder with all of the code for the backend pipeline that you see in this inner gray box here. Now let's proceed with the setup, get everything wired up, running locally as we expect, and then we'll go ahead and deploy this to production. So I'm going to cd into that backend directory. I'm going to get all of my dependencies installed here, and then I'll spin up my local dev server, which will allow me to run this entire backend with local versions of all of these different infrastructure components on my laptop. So I can simulate everything, make sure things work, and then I'll go to production. So my dependencies have been installed. Now to spin up my local infrastructure, I'm just going to run moose dev. And again, this is going to be a complete clone of the infrastructure that I will also have running in production. So I've got containers for my Temporal workflow orchestrator. I've got streaming topics running on a local version of Panda. And then I've got a local ClickHouse instance as well. I also have a local web server for my consumption API, which is running on localhost port 4000, as we can see in this message here. Awesome. So let's give a quick walkthrough of the code. We're going to focus first on kind of the core Moose infrastructure that we are building and powering this application. And all of the most important parts of that code live in this index.ts file. Again, this is in the root of your app folder. And what you might notice is a couple of different components here. I first am defining an ingest pipeline to receive the raw events from the GitHub API. You can see this is very well documented. I've got a ingest pipeline for the transformed events from the raw GitHub event pipeline. I've got the transformation function that's mapping my raw GitHub event to my transformed repo star event as this third line. And then finally, I've got my consumption API defined at the very end of this file. So all of the core components of my data pipeline that you see here are pretty concisely defined in this index.ts file. Now, if you want to actually look at the core business logic that is powering each component here, you can see that I've imported my different data models, my different transformation functions into this index file, and then I'm just passing those in as type parameters or arguments to the different components of my data stack. So if we wanted to look at an example of one of our data models for our raw event pipeline, I can just go ahead and check out the iGithub event type, which we are setting as the type for our ingest pipeline. And what you might notice is it's just a regular TypeScript interface. So we've defined the type, we've passed it as a type parameter to our ingest pipeline, and what we actually get from that is typed infrastructure, including, in this case, an ingest API, a ClickHouse table, and a Red Panda streaming topic that's all configured to this type. And to show you that, I can show you an example of the API, which is being documented automatically in this open API spec. And what you can see is I've got this post API endpoint to ingest a GitHub event, and the sample schema that you see here perfectly aligns to the type definition that we've defined here and passed as a type parameter to that first ingest pipeline. You might also notice that there's no API endpoint for this second pipeline that we've defined, and that's because it's set to false here. So that is exactly what we'd expect. However, if we check our ClickHouse tables, we should see that we do have a table configured for that repo star data model. And what you can see is the columns and the schema of that table is exactly in line with what the schema represents here. Finally, to represent our transformation from the raw GitHub event to the repo star event, we've defined a regular old TypeScript transformation function to map those events. So as you can see, the input is just the source event type, the raw event. It returns the enriched repo star event. And here's the regular function logic to do that. So it's just a regular TypeScript function that we passed as an argument to this @transform, and everything is just wired up behind the scenes and orchestrated for me. The last piece here is on the consumption API side, which you can see as well in our open API spec on the right-hand side here. If we go ahead and look at the route handler definition, once again, it's just a regular TypeScript function that defines our query parameter types as the input, and it returns the expected response body. And then within the function logic, we are just dynamically composing a parameterized SQL query based on the query parameters that we've been provided. We execute that on our ClickHouse table, and then we return the result set to the client. All of the intermediary boilerplate of handling the request parameters and the response formatting is done by the API framework itself. Now, to test it out very quickly, let's just make sure that this works. So let's test out with a few query parameters. For our interval here, let's set our parameter to minute. We'll set our limit to 10, and then we won't set in any parameter on the exclude. We'll go ahead and execute that, and we see values being returned to us. So that is exactly what we're hoping to see. Now we can wire this up to our front end and make sure that that is working. To do that, I'm going to open a new terminal window and cd into the dashboard directory. I'm going to install my dependencies, and then I'll spin up my Next.js local dev server. I'll wire up the connection to make sure that my front end is talking to this backend API correctly. We'll validate that the API request looks correct, and then we'll deploy. So let's run npm run dev to spin up our local dev server here. And our local application is running on port 3000. So let's go ahead and check that out. Go to localhost port 3000 here. It's running. And if we go to our network console, let's double check that the request is being made correctly. So I'm going to go ahead and refresh the page. And when I do that, I should see the request being made to my backend. And as we can see, it's hitting our topic time series API endpoint with the query parameters. Now, if I went ahead and changed my parameters from hour to minute, I should see the latest request being made here. And as you can see in the interval, the value is now minute. So this is wired up correctly. It looks good, and we should be able to now set all of this up in production. So I've gone ahead and taken the first step and created a remote repository on GitHub where I can push my code. And this is what I'm going to need to do, not only to be able to deploy my front-end code on Vercel, but I'm also going to be able to need to do this to deploy my Moose backend code on Boreal. So I'm going to push my code to the repository, and I should now refresh my repository, and I see my code. Awesome. I'm ready to go with Boreal. So Boreal, again, is the cloud hosting platform for your Moose projects. And this is an example of what your homepage will look like once you've onboarded and created your first organization. I'm going to create a new project. And to do that, I just hit this new project button in my dashboard. And now I'll be prompted to select a repository to import. So I'm going to use this GitHub Trends demo that I just created. And I'm going to change my project root because I only want this to grab the Moose backend code, which is nested within my mono repo here. So I'm going to save that and I'm going to hit create project. Now this is going to trigger my deployment. You can play this fun little game while you're waiting for your deployment to complete. It should take about 10 minutes. And once that's done, we'll come back and get this set up. While we wait for that, however, let's deploy our front-end application to Vercel. So I'm going to switch over to my Vercel organization home. And I'm going to go through a similar flow here where I'll add a new project and I'll import my recently created repository here, and we'll change our root to be our dashboard code. Let's hit continue and we'll deploy that. We've got our Boreal project deployed to production as well as our Vercel project, but there's one last step that needs to happen to make sure that your production front end and your production back end are wired together. So if we go ahead and look at our Next.js front end here, what you'll see is there's no data being shown in the dashboard like what we had in development mode. And the reason why is if we look at the network tab, we'll see that the request to the Moose API is being made to localhost port 4000 instead of our production web server running in Boreal. So let's update our environment variables in Vercel to correctly point to our Boreal hosted project as opposed to localhost. Now, in your project, when you created it from the template, you'll see there's an example at .m file here, and this contains the name of the environment variable that you'll need. So I'm going to go ahead and copy that, go over to Vercel. In my project settings here, I have my environment variable tab open, and I'm going to create a new environment variable with the key I just copied. And then to get the value of that, my Boreal URL is in my project dashboard in this top bar right here. So I can copy that, paste that in, hit save here, and then trigger a redeployment. And once that happens, I should expect for my front end to actually start showing real data. So let's wait for that to complete. Let's view our deployment, and it looks like it's building. Now, while we do that, you're also going to need to set some environment variables on your Boreal side. You're going to need to set this Moose URL environment variable to that same URL that we set in our Vercel environment. And then you'll also need to set a GitHub token environment variable to a GitHub personal access token. Similarly, in the Moose code that you get, you have an example environment file here. And what you'll also notice is there's a link to a guide hosted on GitHub for how to create a personal access token. So if you don't have one, follow those instructions. And once you have your token, you can go ahead and create the environment variable, save it, and redeploy. If we switch back over to our Vercel deployment, we should see that by now it has completed, and in fact it has. So let's open the preview and we have data. So everything is wired up. We see the production data flowing into our dashboard here, and everything looks good. So that's it for this side of the tutorial. I'll pass things over to my colleague Joj. He's going to take it from here and make this a heck of a lot better and show you how Aurora, our AI agent, can help you quickly iterate on your insights and your front end features that are consuming them.